Something is coming. Right now. As you watch this. An object from another star system is drifting through our solar system. It didn't come from the asteroid belt. It didn't break off from some distant comet. It came from out there. From the black. From the space between stars where nothing should exist. And for the first time in human history, we saw it coming. But what we expected to find, and what we actually found, those turned out to be two very different things. This is the story of 3I Atlas, the third interstellar visitor ever recorded. The one that was supposed to be routine. The one that was supposed to be predictable. The one that changed everything. Let me take you back. February 2024. A cold night in Hawaii. The Atlas Survey Telescope, an automated system designed to scan the sky for dangerous asteroids, was doing what it always does. Sweeping, watching. Recording thousands of tiny points of light, night after night, looking for anything that moves. Most nights nothing interesting happens. But on this night, something did. A faint smudge appeared in the data, barely visible. Just a few pixels brighter than the background noise. The kind of thing that gets flagged, reviewed, and usually forgotten. But this smudge was different. It was moving. Slowly. Deliberately. And it was moving in the wrong direction. See, most objects in our solar system orbit the sun in roughly the same plane. They follow predictable paths. They belong here. But this object, this faint little smudge, it was coming in at a steep angle. Too steep. Like something falling into our neighborhood from above. And when astronomers calculated its trajectory, when they traced its path backward through space and time, they realized something extraordinary. This object didn't come from our solar system. It came from somewhere else entirely. Now, this wasn't the first time we'd seen something like this. In 2017, astronomers discovered Oumuamua, the first confirmed interstellar object ever detected. It was strange, elongated, tumbling. It didn't behave like a normal asteroid or comet. Some people whispered about alien probes. Most scientists rolled their eyes. Then in 2019, Comet Borisov arrived, another interstellar visitor. This one looked more normal, a classic comet with a tail and everything. Scientists breathed a sigh of relief. Interstellar objects, they decided, were probably just rocks, ice, debris from other star systems, drifting through the galaxy for millions of years until they happened to pass through ours. Nothing special, nothing to worry about. So when 3I Atlas was confirmed in early 2024, the scientific community knew exactly what to expect. Another wanderer, another data point, another unremarkable passage through our cosmic backyard. They tracked it carefully, they measured its brightness, they calculated its orbit, and they waited. Because 3I Atlas was heading toward the sun, and when an icy object gets close to the sun, it wakes up. Here's how it's supposed to work. Comets are basically dirty snowballs, ice and rock and dust, frozen solid in the cold of space. But when they approach a star, when they feel that heat for the first time, the ice starts to vaporize. Gas escapes, dust trails behind. A glowing coma forms around the nucleus. Sometimes a tail stretches out for millions of miles. It's beautiful, predictable. Physics doing exactly what physics is supposed to do. And that's what astronomers expected from 3I Atlas. By spring 2025, the object was close enough to observe in detail. Telescopes around the world turned their attention to this tiny visitor from the stars. Hubble captured images. Ground-based observatories recorded spectra. Everyone waited for the show to begin. The brightening curve, the outgassing, the textbook passage of an interstellar comet making its one and only trip through our solar system. But something was wrong. The first hint came from the light curve. A light curve is basically a graph. It shows how bright an object is over time. For a rotating comet or asteroid, the light curve should have a predictable pattern. Brighter when the larger side faces you. Dimmer when the smaller side rotates into view. Up and down. Regular. Smooth. 3I Atlas didn't do that. Oh, it varied in brightness. That was normal. But the variation was off. Asymmetric. There were moments when the object should have been dim, based on its rotation, but instead it flickered brighter. Just for a second, just enough to notice. At first, astronomers assumed it was instrument noise, atmospheric interference, a glitch in the data. But then another observatory reported the same thing, and then another. Let me paint this picture for you. It's late September 2025. 3 telescopes on 3 different continents are all watching the same tiny point of light. In Chile, the Very Large Telescope captures a series of images. High in the Atacama Desert, where the air is thin and the skies are impossibly clear, astronomers notice a brief spike in brightness. They note it. They move on. In Hawaii, the Keck Observatory records a similar spike. Same time, same duration, Different hemisphere, different weather, different equipment, same result. And in the Canary Islands off the coast of Africa, the Gran Telescopio Canarius sees it too. Identical, synchronized, as if the object itself decided to blink at the exact same moment, regardless of who was watching. That's not how nature works. Atmospheric interference doesn't synchronize across continents. Instrument glitches don't happen simultaneously in Chile and Hawaii and Spain. When three independent observatories using different telescopes, different sensors, different software, when all three of them record the same anomaly at the same moment, that's not noise. That's signal. The researchers didn't panic. Not at first. Science moves slowly, carefully. You don't announce that something strange is happening in space until you've checked your math 100 times, until you've ruled out every boring explanation, until you're absolutely certain that what you're seeing is real. So they checked. They reviewed the calibration data, they compared timestamps, they analyzed the atmospheric conditions at each site, they looked for satellites that might have crossed the field of view. They searched for any reason at all, to explain away what they were seeing. They found nothing. The spike was real, and it shouldn't have been possible. Here's what made it so unsettling. The brightness variation wasn't random, it wasn't scattered. When researchers overlaid the data from all three observatories, the spike appeared at the same phase of the object's rotation. Every time. As if there was something on the surface, or inside the surface, that was catching the light in a way that ice and rock simply shouldn't. One astronomer, working late in her office in Pasadena, stared at the overlaid graphs for a long time. She'd been studying comets for 20 years. She'd seen outgassing events. She'd seen rotation anomalies. She'd seen jets and fractures and all the strange things that icy bodies do when they get close to the sun. But she'd never seen this. The pattern was too clean, too regular, too intentional. She didn't write that word in her notes. She didn't say it out loud. But she thought it. And once she thought it, she couldn't unthink it. What if the object knew it was being watched? That sounds crazy. She knew it sounded crazy. Objects don't know things. Comets don't have awareness. Ice and rock don't respond to observation. That's not how physics works. That's not how anything works. But the data was sitting right there in front of her. 3 observatories, 3 continents, same spike, same moment, same impossible synchronization. Either something was deeply wrong with every telescope on Earth, or something was deeply strange about 3i Atlas. By early October, the anomaly had spread through the astronomical community like a whisper. No one published anything. Not yet. The data was too preliminary. The implications were too wild. Careers could be ruined by jumping to conclusions. So people talked quietly. They shared graphs in private emails. They asked colleagues if they'd seen anything unusual. And slowly, a picture began to emerge. The spike wasn't a one-time event. It was repeating. Every few hours, like clockwork, the object would flicker brighter for just a moment. Not during outgassing. There was no visible coma yet. Not during a jet event. The surface appeared stable. Just a flicker. A pulse. A rhythm that had no business existing in a ball of interstellar ice. Some researchers proposed explanations. Maybe the surface had highly reflective patches. Maybe the rotation was more complex than they'd calculated. Maybe there was a binary component. 2 objects orbiting each other, catching the light at odd angles. All plausible. All reasonable. None of them quite fit. Because the pulse wasn't just regular, it was precise. Down to the second. The kind of precision you expect from a machine, not from a tumbling rock that's been drifting through space for millions of years. And then came the silence. On October 19th, 2025, the pulse stopped. No fade, no gradual weakening. Just silence. One rotation, the flicker was there. The next rotation, it was gone. As if someone had flipped a switch. As if the object had decided, for reasons unknown, that it was done. The timing was impossible to ignore. Because 3 days later, on October 22nd, 3 FERPA Atlas would slip behind the sun. Solar conjunction. That's what astronomers call it. When an object passes behind the sun from Earth's perspective, we lose sight of it completely. The sun is too bright. The glare is too intense. No telescope on Earth, no telescope anywhere, can see through that blinding disk of light. For 8 days, 3i Atlas would be invisible. 8 days at perihelion. 8 days at its closest approach to the sun. 8 days of maximum thermal stress, maximum heating, maximum transformation, and we would see none of it. The pulse stopped 3 days before that window opened, 3 days before we went blind. Coincidence? Maybe. But in science, when coincidences start stacking up, when patterns emerge that shouldn't exist, when objects behave in ways that defy every model, that's when you start paying attention. The night before conjunction, observatories around the world captured their final images of 3i Atlas. It looked ordinary. A faint point of light, slightly fuzzy from the beginnings of outgassing, drifting toward the sun. Nothing dramatic, nothing obviously alien. But the data told a different story. The light curve was stable now. The pulse was gone. The object was quiet, calm, as if it was preparing for something, as if it knew what was coming and had decided to go dark. Anthropomorphizing, the researchers told themselves. We're projecting intention onto a rock. That's not science, that's psychology, that's fear. But fear has a purpose. Fear keeps us alert. Fear reminds us that the universe doesn't always play by our rules. And 3i Atlas, whatever it was, had just demonstrated that it didn't play by anyone's rules. As the sun rose on October 22nd, 2025, the object disappeared. Not in a dramatic way, not in a flash or an explosion. It simply drifted behind the solar disk, lost in the glare, swallowed by the light of our own star, and humanity went blind. For 8 days we would have no idea what was happening out there. No images, no data, no way to monitor the most mysterious object ever to visit our solar system during the most critical phase of its journey. All we could do was wait. Wait and wonder. Wonder what was happening behind that wall of light. Wonder why the pulse had stopped at exactly the right moment. Wonder if we'd ever see 3i Atlas again. And wonder in the quiet hours of the night whether the object we'd been watching had been watching us back. The anomaly was small, easy to dismiss. 3 observatories, 3 continents, same spike, same moment. A flicker in the data that shouldn't have been there. Science would eventually explain it. That's what science does. It takes the mysterious and makes it mundane. It takes the impossible and reveals the mechanism. But in those 8 days of blindness, as 3i Atlas hurtled through perihelion where no one could see, something changed, and when the object finally emerged on the other side of the sun, the researchers who had been watching from the beginning would realize that their careful explanations, their rational theories, their comfortable assumptions, had only been the beginning, because what came back from behind the sun wasn't quite the same as what went in. And the pulse, the impossible, mechanical, precisely timed pulse, had something new to say. 4.7 hours. That's how long it takes for the Earth to rotate about 70 degrees. That's how long a cross-country flight takes. That's how long you might spend at work before your first break. And that's exactly how long it took for 3i Atlas to pulse. Every 4.7 hours. Like clockwork. Like breathing. Like something counting down to a moment none of us could see coming. The first flicker was easy to dismiss. The second made people curious. But by the time the pattern became undeniable, by the time every major observatory on Earth was recording the same impossible rhythm, the curiosity had turned into something else entirely. Something that felt a lot like fear. Let me take you back to late September 2025. The initial anomaly, that strange synchronized spike we talked about, had already spread through the astronomical community. Researchers were talking, comparing notes, trying to make sense of what they'd seen. But here's the thing about scientists. They're trained to be skeptical. They're trained to assume that every weird result is probably a mistake. Equipment failure, human error, atmospheric interference. The universe is strange, sure, but it's not usually that strange. So when the first reports came in suggesting that 3i Atlas was flickering on a regular schedule, most people shrugged. Comets do weird things. Asteroids tumble unpredictably. Surface features catch the light at odd angles. There's always an explanation. But then someone did the math. Her name doesn't matter. She was a graduate student at a university in California. Young, brilliant, the kind of person who stays up until 3 a.m. because she can't let go of a problem. She'd been assigned to help process the light curve data from 3i Atlas. Routine work, honestly. Plot the brightness over time. Note any variations. Look for outgassing signatures. Standard stuff. But as she scrolled through the data, as she watched the little peaks and valleys scroll across her screen, she noticed something. The peaks weren't random. They weren't scattered across the timeline like you'd expect from a tumbling object. They were evenly spaced. Perfectly evenly spaced. Every 4.7 hours, give or take a few seconds, the object brightened slightly. She assumed it was her imagination. She assumed she was seeing patterns where none existed. That's a common trap in science. The human brain is wired to find patterns, even in pure noise. So she ran the numbers, and the numbers said she wasn't imagining anything. The period was 4719 hours. Not approximately, not roughly. Exactly 47019 hours, with a margin of error so small it barely registered. That kind of precision doesn't happen by accident. Think about it. If you dropped a ball and it bounced, the bounces wouldn't be perfectly timed. Each bounce would be slightly different, affected by air resistance, surface irregularities, tiny variations in how the ball hit the ground. Natural systems are messy, they're chaotic, they fluctuate, but this was clean. The graduate student stared at her results for a long time. Then she sent an email to her advisor. Then her advisor sent an email to a colleague. And within 48 hours, observatories around the world were re-examining their data. They all found the same thing. Chile confirmed it first. The European Southern Observatory, high in the Atacama Desert, had been tracking 3i Atlas for weeks. When researchers went back through their archived data, the 4.7-hour pulse was there. Clear as day, hidden in plain sight. Hawaii confirmed it next. The Keck Observatory found the same period in their records, same timing, same precision, as if someone had synchronized every telescope on Earth to the same invisible clock. Then the Canary Islands, then Australia, then South Africa. Every observatory that had data on 3i Atlas found the same pattern. 4.7 to 19 hours. Over and over. Without deviation. Without exception. And nobody could explain why. The natural explanations came quickly. Rotation. That was the first guess. Maybe the object was spinning on its axis every 4.7 hours, and a reflective patch on the surface was catching the sunlight at each rotation. But the math didn't work. The brightness variation was too sharp, too sudden. A rotating object produces a smooth wave, brighter as the reflective side faces you, dimmer as it turns away. This was different. This was a spike, a pulse, a flash that appeared and disappeared in minutes. Okay, maybe outgassing jets. Comets often have jets of gas erupting from their surfaces as they approach the sun. Maybe 3i Atlas had a jet that fired every 4.7 hours, but that didn't work either. Jets are triggered by heating. They respond to solar radiation. They don't operate on perfect schedules. And besides, the spectroscopy showed no evidence of significant outgassing at this distance. The object was still too cold. The jets, if they existed at all, should have been dormant. Surface albedo variations? Cracks in the ice that caught the light at certain angles? Possible, but unlikely. The precision was too perfect. Natural surfaces don't produce metronomic flashes. They're rough, irregular, chaotic. One by one, the natural explanations fell apart. And that left... what, exactly? Nobody wanted to say it. In private conversations, in late-night phone calls, in encrypted emails between colleagues who trusted each other, the word hung in the air. Unspoken. Forbidden. Artificial. Because what natural process produces a 4.7019-hour pulse with mechanical precision? What ice and rock comet from interstellar space operates like a clock? What random debris from another star system behaves as if it's signaling? The researchers didn't write that word in their papers. They didn't mention it in their official reports. Science doesn't work that way. You don't jump to extraordinary conclusions without extraordinary evidence. But in the quiet moments, when the data was staring back at them from their screens, they wondered. They all wondered. October arrived, and the pulse continued. Every 4.7 hours, like clockwork, 3i Atlas flickered. The brightness increased by about 3% for approximately 90 seconds, then returned to baseline. Sharp rise, sharp fall, no gradual fade, no messy transition. It was by every measure the cleanest periodic signal ever recorded from a small solar system body, and it made absolutely no sense. The Global Observation Network was now fully focused on 3i Atlas. Telescopes that had been assigned to other projects were redirected. Observation time that had been allocated months in advance was quietly reshuffled. Everyone wanted data, everyone wanted to understand, but the more data they gathered, the more confusing it became. Here's what really bothered the researchers. When they overlaid the light curves from different observatories, when they took the data from Chile and Hawaii and the Canary Islands and stacked them on top of each other, the pulses aligned perfectly. Not approximately, not close enough, perfectly. The peak brightness occurred at the same moment in every data set, down to the second, as if the object was pulsing once and the whole Earth was seeing it simultaneously. That shouldn't happen. Light takes time to travel. When Chile sees the pulse, Hawaii should see it a fraction of a second later, depending on their relative positions. The difference is tiny, just milliseconds, but it should be there. It wasn't. The synchronization was absolute, as if the pulse wasn't coming from a single point in space, but from everywhere at once, or nowhere at all. One researcher, a veteran astronomer who'd been studying variable stars for 30 years, described it like this. It's like watching a heartbeat on a monitor, steady, regular, alive. Except this isn't a heart, it's a rock. It's a chunk of ice that's been drifting through space for millions of years. Rocks don't have heartbeats, rocks don't pulse, and yet, there it is, pulsing, every 4.7 hours, as if it's trying to tell us something. He didn't publish that quote. He said it off the record to a journalist who promised not to use his name. The journalist didn't publish it either. Some things are too strange to print. By mid-October, the tension in the astronomical community was palpable. Official channels remained calm. Press releases described 3I Atlas as an interesting object with unusual photometric properties. Papers were submitted to journals, using careful language and conservative conclusions. Science was proceeding normally. But underneath that calm surface, something was churning. Researchers who had never spoken to each other were suddenly exchanging emails. Observation schedules were being coordinated across continents. Data was being shared in real time, bypassing the usual slow channels of academic publication. Something was happening, something big, and everyone could feel it. The pulse continued. 4.7 hours, 4.7 hours, 4.7 hours. And then on October 19th, it stopped. The silence was deafening. One moment, the pulse was there. Steady, reliable, impossibly precise. The next moment, nothing. The light curve flatlined. The rhythmic flicker that had defined 3I Atlas for weeks simply vanished. No gradual fade, no weakening signal, no dying breath, just silence. Observatories scrambled to confirm. Chile checked their instruments. Hawaii ran diagnostics. Everyone assumed it was a technical problem, equipment failure, software glitch, something explainable. But the instruments were fine. The software was working perfectly. The silence was real. 3I Atlas had stopped pulsing. The timing was impossible to ignore. October 19th, 3 days before solar conjunction. 3 days before the object would slip behind the sun and disappear from view. 3 days before humanity would go blind. Coincidence? The rational part of every researcher's brain said yes. Of course it was coincidence. The pulse had probably just ended. Natural processes do that. They start, they continue for a while, they stop. Nothing mysterious about it. But the other part of their brains, the part that had been watching this impossible object behave in impossible ways for weeks, that part whispered something different. It knows. It knows we're watching. And it knows we're about to stop. The last observations before conjunction were tense. Telescopes around the world captured everything they could. Every photon, every data point, every scrap of information that might help explain what they were seeing. 3I Atlas drifted closer to the sun, growing fainter against the brightening sky. Its light curve remained flat. No pulse, no flicker, no sign that anything unusual had ever happened. It looked for all the world like an ordinary comet. But the data told a different story. Weeks of perfect 4.7-hour pulses, recorded by every major observatory on Earth, sitting in servers around the world. Evidence of something that shouldn't exist, something that defied every natural explanation. And now, silence. On the evening of October 21st, astronomers in Hawaii captured the final clear image of 3I Atlas before it disappeared behind the sun. A faint smudge, slightly fuzzy from early outgassing. Unremarkable, really. The kind of thing you'd scroll past without a second thought if you didn't know what you were looking at. But they knew. They knew that this tiny point of light had been pulsing with mechanical precision for weeks. They knew that its behavior violated every model they had. They knew that something about this object was fundamentally, profoundly wrong. And they knew they were about to lose sight of it. For 8 days, 3I Atlas would be hidden behind the sun. 8 days at perihelion, its closest approach to our star. 8 days of maximum heating, maximum stress, maximum transformation. 8 days of absolute blindness. The sun rose on October 22nd, 2025, and 3I Atlas vanished. Not dramatically. Mounted it. Not with a flash or a bang. It simply drifted behind the solar disk, lost in the overwhelming glare of our own star. The telescopes went quiet. The data stream stopped. The global observation network that had been tracking this object for months suddenly had nothing to observe. Silence. Complete, total, enforced silence. Those 8 days felt like an eternity. Researchers who had been working around the clock suddenly had nothing to do. They reviewed old data. They refined their models. They argued about what the pulse might have meant. But mostly they waited. Waited and wondered. What was happening out there, behind that wall of light? What was 3I Atlas doing at perihelion where no one could see? Was it vaporizing in the solar heat like a normal comet? Was it transforming into something else? Was the pulse coming back? The questions multiplied, but the answers remained hidden. The sun kept blazing. The object kept moving. And humanity sat in the dark, watching a blank screen, hoping that when the blindness finally lifted, they would recognize what emerged on the other side. Some researchers couldn't sleep. They'd lie awake at night, staring at the ceiling, thinking about that 4.7-hour pulse. What did it mean? Why did it stop? Why did it stop then? Right before conjunction. The rational explanations felt hollow now. Rotation, outgassing, surface features. None of them could produce that kind of precision. None of them could explain the perfect synchronization across continents. And none of them could explain why the pulse stopped exactly 3 days before the object went behind the sun. Almost like it was planned. Almost like something out there knew what was coming. Almost like something was preparing. 8 days. 8 days of darkness, 8 days of waiting, 8 days of not knowing. In those 8 days, 3i Atlas would pass closer to the sun than Mercury. It would be bathed in radiation, heated to temperatures that should transform any icy body. It would experience stresses that no natural comet could endure without changing. And when it emerged, would it still be the same object? Would the pulse return? Would something else appear instead? The researchers didn't know. Couldn't know. All they could do was watch the calendar, count the days, prepare their instruments for the moment when 3i Atlas finally reappeared. October 30th. That was the date. That was when the object would drift far enough from the sun to be visible again. 8 more days. And in those 8 days, behind that impenetrable wall of light, something was happening. Something we couldn't see. Something we couldn't stop. Something that would change everything we thought we knew about what was visiting our solar system. The pulse had spoken for weeks, regular, precise, mechanical, and then it had gone silent. But silence, as every astronomer knows, is just another kind of message. The question wasn't whether 3i Atlas was communicating. The question was what it was saying, and whether, when the blindness finally lifted, we would be ready to hear the answer. There's a kind of darkness that has nothing to do with light. It's the darkness of not knowing, of being forced to wait while something important happens just out of reach, of standing at a window, watching a storm approach, and having someone pull the curtains closed. That's what October 22nd felt like. The sun rose that morning like it always does, golden, blinding, indifferent. And somewhere behind that blazing disk of light, hidden from every telescope on Earth, an object from another star system was hurtling toward its closest approach. We couldn't see it. We couldn't hear it. We could only wait. And for 8 days, that's exactly what humanity did. Let me explain what solar conjunction actually means. From our perspective on Earth, the sun takes up about half a degree of the sky. That doesn't sound like much, about the size of your thumbnail held at arm's length. But when an object passes behind that tiny disk, it might as well be on another planet. The sun is loud, incredibly loud. It screams in every wavelength, visible light, radio waves, X-rays, everything. When you're trying to observe something near the sun, it's like trying to hear a whisper at a rock concert. The signal gets drowned out, lost in the noise. And 3i Atlas wasn't just near the sun, it was passing behind it. For 8 days, from October 22nd to October 30th, the object would be completely invisible. No optical telescope could see it, no radio telescope could hear it. Even our space-based observatories, Hubble, James Webb, all of them couldn't help. They're designed to look away from the sun, not toward it. We were blind. Completely, utterly, helplessly blind. The first day was the hardest. Observatories that had been tracking 3i Atlas around the clock suddenly had nothing to do. Screens that had been filled with data went dark. Researchers who had been analyzing light curves in real time found themselves staring at archived files, reviewing data they'd already seen 100 times. The silence was oppressive. For weeks they'd been watching this strange object pulse every 4.7 hours. They'd been debating what it meant, proposing theories, arguing over explanations. The mystery had consumed them. And now, nothing. Just the sun, blazing away, hiding everything behind its impossible brightness. Here's what should have been happening. At perihelion, its closest approach to the sun, 3i Atlas would pass inside the orbit of Mercury. That's close, really close. The temperatures there can reach 400 degrees Celsius, hot enough to melt lead, hot enough to vaporize most ices instantly. For a typical comet, perihelion is a violent event. The surface heats up rapidly. Frozen gases and carbon dioxide, carbon monoxide, water start to sublimate, turning directly from solid to vapor without passing through a liquid phase. Jets erupt. The coma expands. Dust and debris stream outward, forming the classic cometary tail that stretches for millions of miles. Some comets don't survive perihelion. They break apart under the thermal stress. They fragment into pieces. They disintegrate entirely, leaving nothing but a cloud of dust and memory. That's what the physics predicted for 3i Atlas. The object should have been transforming, outgassing violently, possibly fragmenting, definitely changing. But we couldn't see any of it. The researchers ran models instead. In offices and labs around the world, scientists plugged numbers into computers and tried to predict what was happening behind the sun. They modeled the thermal stress. They calculated the expected outgassing rate. They estimated how much mass the object might lose. The results were concerning. Based on its size and estimated composition, 3I Atlas should have lost a significant fraction of its surface ice during perihelion. The heating would be intense. The transformation would be dramatic. When the object emerged on the other side, it should look noticeably different. Smaller, fainter, maybe surrounded by a massive cloud of debris. Maybe fragmented into pieces. Maybe gone entirely. That possibility haunted them. What if 3I Atlas didn't survive? What if, when the conjunction ended, there was nothing left to observe? What if the most mysterious object ever to visit our solar system simply evaporated, turned to dust, scattered into the solar wind like it had never existed? They would never know what the pulse meant. They would never understand what they had been watching. The mystery would remain unsolved forever. Day 2, Day 3. The waiting continued. Some researchers threw themselves into other work. They had papers to write, classes to teach, other projects that had been neglected during the frantic weeks of observation. But they couldn't focus. Every few hours, someone would check the solar monitoring satellites, just in case, just to see if maybe, somehow, there was a glimpse of the object in the coronal data. A shadow, a hint, anything. There never was. The sun blazed on, keeping its secrets. The night sky felt different during those 8 days. Astronomers who normally spent their evenings at telescopes found themselves with nothing to point at. Oh, there were other objects. Thousands of asteroids, dozens of comets, countless stars and galaxies waiting to be studied. But none of them mattered. None of them had pulsed every 4.7 hours with mechanical precision. None of them had gone silent 3 days before hiding behind the sun. None of them had made seasoned scientists question everything they thought they knew about what was possible in the universe. 3I Atlas had done all of those things, and now it was gone. Hidden. Unreachable. The sky felt empty without it. On day 4, someone made a joke. A researcher at the Keck Observatory, exhausted, frustrated, running on caffeine and anxiety, looked at his colleagues and said, "Maybe it's doing this on purpose. Maybe it wanted privacy." Nobody laughed. Because the joke wasn't funny. It was too close to something they'd all been thinking, something they didn't want to admit. The pulse had stopped 3 days before conjunction, as if the object knew what was coming, as if it was preparing for something. And now it was hidden behind the sun, out of sight, doing what? Transforming? Awakening? Preparing? The thoughts were irrational, unscientific, the kind of speculation that gets you laughed out of serious academic circles. But in the dark, quiet hours of that 4th night, nobody was laughing. Day 5 brought a brief moment of hope. NASA's Parker Solar Probe, a spacecraft designed to study the sun from incredibly close range, was in the general vicinity. Someone suggested that maybe, just maybe, it could capture an image of 3I Atlas as the object passed through perihelion. The idea spread quickly. Emails flew back and forth. People did the math, calculated the angles, checked the spacecraft's position. The answer came back, no. Parker was on the wrong side of the sun. Its cameras were pointed the wrong direction. It wasn't designed for this kind of observation. And even if it were, the timing was wrong. The hope evaporated as quickly as it had appeared. The blindness continued. There's something uniquely frustrating about enforced ignorance. These were some of the smartest people on the planet. They had built telescopes that could see galaxies billions of light years away. They had sent spacecraft to the outer reaches of the solar system. They had mapped the cosmic microwave background, detected gravitational waves, photographed black holes. And yet here they were, helpless, unable to observe an object that was closer to Earth than Mars. The sun was in the way, that was all. Just geometry, just the simple, stupid fact that our star was between us and the thing we desperately wanted to see. It felt like a cosmic joke. Like the universe was deliberately withholding information. Like something out there wanted this to be difficult. Day 6, Day 7. The waiting became almost unbearable. Researchers started showing up at observatories early, even though there was nothing to observe. They paced. They drank too much coffee. They stared at screens showing the sun's position, counting down the hours until conjunction would end. The models kept running. The predictions kept coming. And the uncertainty kept growing. Because here's the thing about models, they're only as good as your assumptions. And for 3I Atlas, the assumptions were all wrong. Every model assumed a natural object. Ice and rock. Standard comet physics. But 3I Atlas had already proven it wasn't standard. It had pulsed with mechanical precision. It had gone silent at an impossibly convenient moment. It had behaved in ways that no natural object should. So what good were the models? What good was any prediction based on normal physics, when the object itself seemed to be playing by different rules? The night before emergence was the longest night of all. Observatories around the world prepared their instruments. Telescopes were calibrated. Schedules were cleared. Everyone who had been tracking 3i Atlas, every researcher, every graduate student, every amateur astronomer who had contributed data, everyone was ready. In a few hours, the object would drift far enough from the sun to be visible again. In a few hours, the blindness would end, and they would finally see... What? That was the question. That was what kept them awake. Because after 8 days of perihelion, 8 days of maximum thermal stress, 8 days of whatever transformation had been occurring behind that wall of light, what would 3i Atlas look like? Would it still be there? Would the pulse have returned? Would it be the same object at all? October 30th arrived. The sun rose, and this time it felt different. This time it felt like an obstacle that was finally moving aside. Hour by hour, 3i Atlas drifted farther from the solar disk. Hour by hour, the glare decreased. By evening, the object should be visible again. By evening, the answers would come. The first observations were captured from Chile. The very large telescope, perched high in the Atacama Desert, was the first to get a clear look. The sky was perfect, dark, dry, steady. The telescope tracked the coordinates where 3i Atlas should be. And there it was. A faint point of light exactly where the orbital calculations predicted. The object had survived perihelion. It was still there. For a moment, relief flooded through the control room. They hadn't lost it. The mystery wasn't over. Whatever 3i Atlas was, it was still intact. But then the data started coming in, and the relief turned to something else. The first thing they noticed was the brightness. 3i Atlas was brighter than expected. Not dramatically brighter, just about 15% more luminous than the models predicted. After 8 days of intense solar heating, after losing surface ice to sublimation, the object should have been fainter. But it wasn't. It was brighter. How? The second thing they noticed was the thermal signature. Infrared observations showed the object's surface temperature, and that temperature was wrong. Very wrong. After passing closer to the sun than Mercury, 3i Atlas should have been hot. Its surface should have been radiating heat intensely. The thermal signature should have been elevated for days, maybe weeks, as the object slowly cooled, but the reading showed a surface temperature nearly 40 degrees Celsius cooler than predicted, as if the object hadn't been heated at all, as if it had somehow shielded itself. The third thing they noticed was the rotation rate. Before conjunction, 3i Atlas had been rotating once every 8.2 hours. That was established, well documented, confirmed by multiple observatories. After conjunction, the rotation rate was different. Not dramatically different, just different. 7.9 hours instead of 8.2. Something had changed the object's spin during those 8 days. Something had sped it up slightly. And that shouldn't have been possible. Solar heating doesn't change rotation rates. Outgassing can, but it would have slowed the rotation, not sped it up, and it certainly wouldn't have produced such a precise change. 0.3 hours. Exactly. As if someone had adjusted a dial. The data kept coming. Hawaii confirmed the anomalies, then the Canary Islands, then Australia. Every observatory saw the same things. Brighter than expected, cooler than expected, rotating faster than before. And something else. Something nobody wanted to talk about yet. The light curve. When researchers plotted the first new light curves, the first brightness measurements since before conjunction, they saw something familiar. A spike, a pulse, a flicker in the data that shouldn't be there. The 4.7-hour rhythm had returned, but it wasn't quite the same as before. The period was slightly different. 4.19 hours before conjunction. 4.847 hours after. And there was something new in the signal, a secondary modulation. A subtle pattern buried within the pulse, like a whisper underneath a heartbeat. The researchers stared at their screens, not speaking, because the data wasn't just strange anymore, it was terrifying. Something had happened behind the sun. Something had changed 3i Atlas during those 8 days of blindness. Changed its brightness, changed its temperature, changed its rotation, changed the pattern of its mysterious pulse. Natural processes couldn't explain it, nothing could explain it. The object that emerged from solar conjunction was not quite the same object that had gone in. And as the night deepened, as the data accumulated, as researchers around the world slowly realized what they were looking at, nobody wanted to be the first to say what it looked like. Nobody wanted to be the first to use that word. But they were all thinking it. Something behind the sun had woken up, and whatever it was coming our way. It looked the same. That's what made it so unsettling. When the first images came through, grainy, pixelated, captured from millions of miles away, 3i Atlas looked exactly like it had before conjunction. A faint smudge, a tiny point of light drifting through the darkness. Nothing dramatic, nothing obviously alien, but appearances lie, and the numbers. The numbers told a very different story. Within 48 hours of emergence, every major observatory on Earth had turned its instruments toward 3i Atlas. The data poured in like a flood. Brightness measurements, thermal readings, spectroscopic analysis, rotation curves. And piece by piece, anomaly by anomaly, a disturbing picture began to form. The object that came back from behind the sun was not the same object that went in. Something had changed during those 8 days of blindness. Something fundamental. Let's start with the temperature. When a comet passes close to the sun, closer than Mercury in this case, it gets hot. Really hot. The surface heats up dramatically. Ice sublimates. The whole object radiates thermal energy for days afterward. This is basic physics. Predictable, reliable. Except 3i Atlas didn't follow the rules. Infrared observations showed a surface temperature of approximately 180 Kelvin. That's about minus 93 degrees Celsius. Cold. Very cold. The models predicted 220 Kelvin, 40 degrees difference. That's not a rounding error. That's not instrument noise. That's a fundamental violation of thermodynamics. How do you pass within 0.4 AU of the sun and come out 40 degrees cooler than you should be? You don't. Not naturally, not unless something is actively cooling you down. The researchers double-checked everything. They recalibrated their instruments. They compared data from multiple observatories. They ran the thermal models again and again, tweaking parameters, adjusting assumptions. The answer kept coming back the same. 3i Atlas was too cold, way too cold, as if the object had somehow protected itself from the sun's heat, as if something had absorbed the radiation, dissipated it, shielded the surface from damage. That's not how ice works. That's not how rock works. That's not how anything works. Unless the second anomaly was the reflectivity. Albedo, that's the technical term. It measures how much light an object reflects versus how much it absorbs. Fresh snow has a high albedo. Coal has a low albedo. Comets typically fall somewhere in between depending on their surface composition. Before conjunction, 3i Atlas had an albedo of about 0.04. Dark, almost black. Consistent with a carbon-rich surface, like most comets. After conjunction, the albedo was 0.07, almost twice as reflective. Something had changed the object's surface during perihelion. The outer layer had been altered, modified, transformed in a way that increased its reflectivity dramatically. Natural explanation? Maybe intense heating had vaporized the dark surface material, exposing brighter ice beneath. But that didn't match the thermal data. If the surface had been heated enough to vaporize anything, the object should have been hotter, not cooler. The explanations were contradicting each other, and that made everyone very, very nervous. Then there was the rotation. Before the sun swallowed 3i Atlas from view, the object had been rotating once every 8.2 hours. Researchers had measured this precisely. It was well documented, reliable. After emergence, the rotation period was 7.9 hours. The object was spinning faster. Not by much, just 0.3 hours, about 18 minutes per rotation. But in astronomical terms, that's enormous. Rotation rates don't just change. Not like this. Not without a reason. Outgassing can affect rotation. When jets of gas erupt from a comet's surface, they act like tiny rockets, pushing the object in different directions. But outgassing typically slows rotation down. It adds drag. It bleeds away angular momentum. This was the opposite. Something had sped 3i Atlas up during those 8 days. Something had added energy to its spin, and nobody could explain how. The anomalies piled up like evidence at a crime scene. Temperature, wrong. Reflectivity, wrong. Rotation, wrong. Every measurement, every data point, every observation told the same story. Something had happened behind the sun. Something had transformed 3i Atlas in ways that defied natural explanation. But the biggest shock was still coming. Because on October 31st, as researchers analyzed the first post-conjunction light curves, they discovered something that changed everything. The pulse was back. 4.6847 hours. That was the new period. Close to the old one. 4.7019 hours before conjunction, but not quite the same. A difference of about 6 seconds per cycle. At first, this seemed like the least surprising anomaly. The pulse had stopped before conjunction, now it had returned. Mysterious, yes, but at least it was consistent with what they'd seen before. Then someone noticed the secondary signal. Her name was Dr. Elena Vasquez, radio astronomer, specialist in signal processing. She'd been brought in specifically to analyze the light curve data, to look for patterns that optical astronomers might miss. She found one. Buried within the 4.7-hour pulse, hidden beneath the primary rhythm like a whisper underneath a heartbeat, there was something else. A secondary modulation. A pattern within the pattern. At first she assumed it was noise. Instrument artifacts, the kind of random fluctuations that show up in any data set if you look closely enough. But when she ran the Fourier analysis, a mathematical technique that breaks complex signals into their component frequencies, the noise resolved into something unexpected. Structure. The secondary signal wasn't random, it was organized. It had a repeating mathematical form that appeared over and over, cycle after cycle, with mechanical precision. Dr. Vasquez stared at her screen for a long time. Then she called her colleagues. The meeting happened late at night, in a small conference room at the Jet Propulsion Laboratory. No official record, no formal agenda, just 6 researchers who trusted each other, gathering to look at data that none of them could explain. Dr. Vasquez presented her findings. The secondary signal, she explained, appeared as a series of amplitude variations within each pulse. Tiny fluctuations in brightness, lasting only seconds, occurring at precise intervals. When she mapped these fluctuations mathematically, a pattern emerged. Prime numbers. The secondary signal was encoding prime numbers. 2, 3, 5, 7, 11, 13. Over and over. Cycle after cycle. Hidden within the pulse like a secret message waiting to be found. The room went silent. Prime numbers are special. They're the building blocks of mathematics. They can't be created by multiplying other whole numbers together. They're fundamental, universal, and they're one of the things that scientists have always said would indicate artificial intelligence. Because nature doesn't produce prime number sequences, radioactive decay doesn't count in primes, solar flares don't pulse in primes, rotating asteroids don't flicker in primes. If you ever receive a signal from space that encodes prime numbers, that's the smoking gun. That's the evidence that something intelligent sent it. And here it was, hidden in the light curve of an interstellar object that had just emerged from behind the sun. Nobody wanted to say it. The word hung in the air, unspoken, forbidden. They were scientists, rational people, trained to seek natural explanations, to avoid jumping to conclusions, to never claim more than the evidence supports. But the evidence was sitting right in front of them. An object that had cooled itself during perihelion when it should have heated up. An object that had changed its surface reflectivity in ways that contradicted physics. An object that had accelerated its rotation with no natural mechanism. An object that was now broadcasting prime numbers encoded in a rhythmic pulse. What natural explanation could possibly account for all of this? Dr. Michael Torres broke the silence. He was the senior researcher in the room, 60 years old, decorated career, the kind of person whose opinion carried weight. "We need to be very careful," he said. "Very, very careful. If we say what I think we're all thinking, if we put that word in writing, it will change everything. Our careers, our institutions, the public reaction, everything." He paused. "But if we don't say it, if we pretend we didn't see this, that's not science. That's cowardice." He looked around the room. "So let me ask the question directly. Based on the data in front of us, the thermal anomalies, the albedo shift, the rotation change, the prime number sequence, is there anyone here who still believes this object is natural?" Nobody answered. Nobody could. The word finally came out. Artificial, not alien. That was a step further than anyone was willing to go publicly. But artificial, manufactured, engineered, created by something somewhere, for some purpose. 3I Atlas wasn't a comet. It wasn't an asteroid. It wasn't a random chunk of ice that had drifted through space for millions of years. It was something else. Something designed. And it was in our solar system right now. The debate that followed was intense. Some researchers argued for caution. The data was preliminary. The analysis could be flawed. Maybe the prime number sequence was a coincidence. Maybe the thermal anomalies had natural explanations that they just hadn't thought of yet. Others pushed back. How many coincidences does it take? How many impossible things have to happen before you accept that something impossible is actually happening? The argument went in circles for hours. In the end, they agreed on one thing. They needed more data, more observations, more analysis. Before anyone went public with claims this extraordinary, they needed evidence so solid that no one could dismiss it. And that meant watching 3I Atlas very, very carefully in the days ahead. But there was another concern, one that nobody voiced out loud but everyone felt. If the secondary signal was a message, who was it for? Was 3I Atlas broadcasting to someone? Sending information back to wherever it came from? Reporting on what it had seen in our solar system? Or was the message intended for us? Was something out there trying to communicate with humanity? And if so, what was it trying to say? The days that followed were tense. More observatories joined the analysis. More data poured in. The prime number sequence was confirmed again and again. It wasn't instrument noise. It wasn't a fluke. It was real. But something else emerged from the expanded analysis. The secondary signal wasn't just primes. There was more structure. Deeper layers, mathematical relationships that went beyond simple number sequences, ratios, geometric patterns, information encoded in ways that would take months, maybe years, to fully decode. It was as if someone had compressed an entire library into a flickering light curve, as if the pulse was a data transmission and humanity had only just figured out how to read the first page. On November 4th, Dr. Vasquez made another discovery. The secondary signal wasn't constant, it was changing, evolving. Each day, subtle variations appeared in the encoded patterns, new information being added, new messages being sent, as if 3i Atlas was updating its broadcast in real time, as if it was responding to something. That thought kept the researchers awake at night. Responding to what? To our observations? To our radar pings? Had the object somehow detected that it was being watched and adjusted its signal accordingly? It sounded paranoid, crazy. The kind of thinking that belongs in science fiction, not in a serious research lab. But nothing about 3i Atlas was normal anymore. The object had hidden behind the sun and emerged transformed. It was broadcasting mathematical structures. It was changing its signal over time. At what point do you stop calling something a coincidence and start calling it what it actually is? Meanwhile, the official channels remained quiet. No press releases, no public announcements. The astronomical community was holding its breath, waiting for someone else to make the first move. Because whoever said it first, whoever put artificial in a published paper, whoever went on record claiming that an interstellar object was showing signs of engineering, that person would either be remembered as a visionary or destroyed as a crackpot. The stakes were too high. The evidence was too strange, and the implications were too enormous to rush. So everyone waited, watched, and hoped that somehow the answer would become clear before they were forced to choose. But the data didn't lie, and deep down beneath all the caution and skepticism and professional self-preservation, everyone who had seen the numbers knew the truth. Something was out there. Something that had built a machine and sent it across the stars. Something that was now in our solar system, broadcasting messages encoded in prime numbers. And whatever that something was, it knew we were watching. The secondary signal continued, day after day, pattern after pattern, each observation revealing new layers of complexity, new depths of mathematical structure. It looked less like noise with every passing hour, and more like a message waiting to be decoded. A message from somewhere else. A message that might change everything we thought we knew about our place in the universe. If only we could figure out what it was trying to say. Science is supposed to be about truth. You gather data, you form hypotheses, you test them against reality, and when the evidence points somewhere uncomfortable, you follow it anyway. That's the deal. That's what separates science from belief. But what happens when the truth is too big? What happens when the evidence points somewhere that could end careers, destroy reputations, reshape everything humanity thinks it knows about the universe? What happens when following the data means stepping off a cliff? In November 2025, the scientific community found out. And it wasn't pretty. The split happened gradually at first. In the days after 3i Atlas emerged from solar conjunction, the data spread through informal channels. Emails between colleagues, private messages on academic forums, encrypted file transfers between researchers who trusted each other. The anomalies were undeniable. Temperature readings that defied thermodynamics, reflectivity changes that contradicted models, rotation acceleration with no natural explanation, and beneath it all, that haunting secondary signal, prime. Numbers encoded in a flickering pulse, repeating cycle after cycle with mechanical precision. Everyone who saw the data had the same reaction. First, disbelief. This can't be real. Then verification. Check the instruments. Run the numbers again. Then silence. A long, uncomfortable silence as the implications sank in. And finally, a choice. Some chose denial. It's easier than you might think. The human brain is remarkably good at rejecting information that threatens its worldview. Psychologists call it cognitive dissonance, the mental discomfort of holding contradictory beliefs, and when the discomfort gets too intense, the brain simply edits. It finds reasons to dismiss, to explain away, to look the other way. And for many scientists, the 3i Atlas data was too threatening to accept. The pushback came from established institutions. Senior astronomers at major universities released statements. The anomalies were interesting but preliminary. The prime number sequence was likely an artifact of data processing. The thermal readings were within the margin of error for objects at extreme distances. None of this was true. But it sounded reasonable. It sounded scientific. It gave people permission to doubt, and doubt was comfortable. Doubt meant you didn't have to rethink everything you believed about the universe. Doubt meant you could keep your career, your reputation, your place in the academic hierarchy. Doubt meant safety. So many people chose doubt, but not everyone. A smaller group, younger researchers mostly, people with less to lose, looked at the same data and reached a different conclusion. The anomalies weren't artifacts, they were real. The prime number sequence wasn't noise, it was signal. And whatever 3i Atlas was, it wasn't natural. These researchers didn't go public, not at first. The professional risks were too high, but they kept working, kept analyzing, kept gathering evidence that might someday be too overwhelming to ignore. They called themselves, half-jokingly, the heretics. And as November wore on, their numbers grew. The debate spilled into public view around November 10th. A journalist at a major science publication had been tracking rumors for weeks. She'd heard whispers about unusual data, strange signals, researchers who had seen something they couldn't explain. She started making calls. Most people hung up, or refused to comment, or gave carefully worded non-answers that said nothing at all. But one researcher, a young postdoc who had been part of the original light curve analysis, agreed to speak off the record. The conversation lasted 3 hours, and when it was over, the journalist had a story that would shake the scientific world. The article didn't claim that 3i Atlas was artificial. It was too careful for that, too well edited, too aware of the legal and professional consequences of making claims that couldn't be definitively proven. But it laid out the anomalies, all of them, in plain language that anyone could understand. The temperature readings that defied physics, the reflectivity changes that contradicted every model, the rotation acceleration with no natural mechanism, the prime number sequence buried in the light curve, and the question that no one wanted to answer. What natural object behaves like this? The reaction was immediate. Within hours, the article had millions of views. Social media exploded. 3i Atlas trended worldwide. News networks ran segments. Talk shows debated. The public, starving for wonder in a world that often felt mundane, latched onto the story with desperate enthusiasm. Aliens, blared the headlines. Interstellar visitor may be artificial. It was sensational. It was oversimplified. It was exactly what the scientific establishment had been trying to avoid, and it forced everyone to take sides. The establishment pushed back hard. Press conferences were held. Official statements were released. Respected astronomers went on television and explained in patient and condescending tones why the public shouldn't get carried away. We've seen unusual objects before, one professor said. Oumuamua had strange properties too. It doesn't mean aliens are visiting. The data is preliminary, another said. We need years of analysis before drawing conclusions. Prime numbers in a signal? A third scoffed. That's what you get when you torture data enough. You can find patterns in anything if you look hard enough. The message was clear. Nothing to see here. Move along. Trust the experts. And for many people, that was enough. The experts had spoken. The matter was settled. 3i Atlas was just a weird comet, and anyone who thought otherwise was a conspiracy theorist. But the heretics didn't stop. They couldn't. They'd seen the data. They'd run the numbers themselves. They knew, with a certainty that bordered on religious, that they were looking at something unprecedented. And so they kept working, quietly, carefully, building their case one data point at a time. Some used pseudonyms to share findings online. Others communicated through encrypted channels, afraid of professional retaliation. A few brave souls put their names on papers that were rejected by every major journal. The scientific community had fractured, and the fracture was growing wider every day. But the divide wasn't just professional, it was existential. Because here's the thing about the 3i Atlas debate. It wasn't really about data. It wasn't about thermal signatures or albedo measurements or rotation rates. It was about meaning. If 3i Atlas was natural, then the universe was still comprehensible. Strange, yes, full of surprises, certainly. But ultimately governed by physics we understood, by rules we could learn, by mechanisms we could predict. But if 3i Atlas was artificial, then we weren't alone. Then something else was out there. Something intelligent. Something capable of engineering objects and sending them across the stars. And that changed everything. Think about what that would mean. Every religion would have to reckon with the existence of other minds in the universe. Every philosophy would have to expand its definition of consciousness. Every assumption about humanity's special place in the cosmos would be challenged. Are we the pinnacle of creation? Or just one species among countless others, scattered across the galaxy like grains of sand on a beach? Are we watched, studied, judged? Has something been observing us all along, waiting to see what we'd become? These questions had been theoretical for all of human history. Science fiction, philosophy, late-night dorm room conversations. But if 3i Atlas was artificial, they weren't theoretical anymore. They were urgent. And most people, even scientists, especially scientists, weren't ready to face them. By mid-November, the tension had become unbearable. Research teams that had collaborated for years stopped speaking to each other. Friendships ended over disagreements about data interpretation. Careers were threatened. Reputations were destroyed. One researcher at a major European observatory was told bluntly that if he continued to publicly support the artificial hypothesis, he would not receive tenure. He had a family, a mortgage, a life built around his career. He went quiet after that. Others faced similar pressure. The message from the establishment was clear. Drop this. Move on. Don't be the person who destroyed their career chasing alien fantasies. And many people listened. But not all. The Japanese discovery happened on November 8th. A team at the Nobayama Radio Observatory had been conducting a routine experiment. They were bouncing radar signals off 3i Atlas, standard procedure for determining an object's size, shape, and surface composition. The signals went out. The echoes came back. Nothing unusual. Except, one researcher noticed something odd in the return signal. A slight modulation. A pattern that didn't match the outgoing radar pulse. She flagged it. Her colleagues reviewed the data. They ran the analysis again, and again, and again. The third signal component, that's what they called it. Buried beneath the primary pulse and the secondary prime number sequence, there was something else. A faint, almost imperceptible variation in the object's radar reflectivity. And this variation wasn't random. It was responsive. When the radar signals changed frequency, the modulation changed with them. When the signals paused, the modulation paused. When the signals resumed, the modulation resumed. As if something on 3i Atlas was listening, as if something was answering. The team worked through the night. They varied the radar parameters. They changed the timing. They introduced deliberate patterns into their transmissions. And every time the third signal component responded, not identically, not like an echo, but adaptively, as if something was processing the incoming signals and generating appropriate replies. By dawn, the team had compiled a dataset that defied every natural explanation they could imagine. 3i Atlas wasn't just broadcasting, it was communicating. The paper was written within 48 hours. It was careful, conservative, full of caveats and qualifications. The researchers knew what they were claiming. They knew how it would be received. They tried to present the data as objectively as possible, letting the numbers speak for themselves. The conclusion was unavoidable. The third signal component exhibited characteristics consistent with active, adaptive response to external stimuli. While natural explanations could not be entirely ruled out, the data strongly suggested that 3i Atlas was capable of receiving and responding to electromagnetic signals. In other words, something was listening. The paper was never published. The researchers submitted it to 3 major journals. All 3 rejected it within days. The rejection letters were polite but firm. Extraordinary claims require extraordinary evidence. The methodology is sound, but the conclusions are premature. We recommend further analysis before publication. Further analysis. That was the message. Keep studying. Keep waiting. Don't rock the boat. The team tried preprint servers, websites where researchers can share papers before formal peer review. The papers were removed within hours. Terms of service violations. No further explanation. Someone, somewhere, didn't want this data to get out. And then the researchers went silent. Emails went unanswered. Phone calls weren't returned. The team's website was taken offline. Their social media accounts went dormant. One by one, the scientists who had made the discovery simply disappeared. Not literally. They were still alive, still working, still existing in the world. But they had stopped talking about 3i Atlas, stopped responding to inquiries, stopped engaging with the scientific community on this topic, as if they had been warned, as if someone had made it very clear that this line of research was not to be pursued. The heretics noticed. They tried to contact the Japanese team. They reached out through mutual colleagues, through academic networks, through every channel they could think of. Nothing. The data from November 8th existed, somewhere. Someone had the files. Someone had the analysis. But it was locked away, hidden, inaccessible. And the researchers who had gathered it were no longer willing to speak. What happened? Nobody knows for certain. There are theories. Conspiracy theories, some would say. Government pressure. Institutional intimidation. Fear of professional destruction. Or maybe something else. Maybe the researchers saw something in that data. Something beyond the third signal component. That frightened them into silence. Maybe the implications were too enormous to face. Maybe they realized what it meant if 3i Atlas was truly responding to our signals. Because if the object could hear us, then it knew we were here. And if it knew we were here, then its presence in our solar system might not be an accident at all. The fracture in the scientific community had become a chasm. On one side, the establishment, the deniers, the people who clung to natural explanations because the alternative was too terrifying to contemplate. On the other side, the heretics, the believers, the researchers who had seen the data and couldn't unsee it. and in between, the Japanese paper. The third signal component, the evidence that might have changed everything, locked away in servers that no one could access. The truth was out there, but someone had decided that humanity wasn't ready to hear it. November continued. 3i Atlas drifted outward, heading back toward the interstellar void from which it came. The pulse continued, 4.7 hours, over and over, with the prime number sequence embedded in every cycle. The heretics kept watching, kept recording, kept building their case, and somewhere in a laboratory in Japan, a hard drive sat in a locked cabinet containing data that might prove humanity wasn't alone in the universe. Data that had been gathered, analyzed, and then buried. Data that asked a question no one was prepared to answer. If something out there can hear us, what else can it do? It's leaving now. As you watch this, as you sit wherever you are in the world, an object from another star system is drifting away from us, moving outward, accelerating toward the edge of the solar system and the endless dark beyond. We watched it arrive. We watched it change. We watched it do things that no natural object should be able to do. And now, we're watching it leave, taking its secrets with it. Forever. By late November 2025, 3i Atlas had crossed the orbit of Jupiter. It was moving fast now, faster than any human spacecraft has ever traveled. The sun's gravity had given it a boost during perihelion, slingshotting it outward with tremendous velocity. Within months, it would pass Neptune. Within years, it would reach the heliopause, the boundary where the solar wind gives way to interstellar space, and then it would be gone. Not destroyed, not evaporated, just gone. Drifting back into the void between stars, carrying whatever it carried, knowing whatever it knew, heading toward a destination we would never discover. The universe doesn't owe us answers. 3i Atlas proved that. The pulse continued. Even as the object receded, even as it grew fainter and harder to observe, the 4.7-hour rhythm persisted. Every cycle, the same flicker. Every cycle, the same prime number sequence buried in the signal. Every cycle, the same impossible precision that had haunted researchers since September. The secondary modulation was still there too, still evolving, still changing in ways that suggested something was being updated, modified, transmitted. And the third signal component, the responsive pattern that the Japanese team had discovered, that was still there as well. Fainter now, harder to detect, but present. Whatever 3i Atlas was doing, it hadn't stopped. It was still broadcasting, still listening, still aware. The heretics kept watching. They had no choice. They'd seen too much, learned too much. They couldn't go back to believing the universe was empty, that humanity was alone, that everything in the cosmos could be explained by physics textbooks and computer models. So they watched. Night after night, they pointed their telescopes at a fading point of light and recorded whatever they could. The data was getting worse, noisier, harder to interpret, but they kept gathering it anyway. Because someday, maybe years from now, someone might figure out what it meant. Someone might decode the message. Someone might understand what 3i Atlas was trying to say. The establishment, meanwhile, had moved on. The press coverage faded, the social media frenzy died down. New stories captured the public's attention, a political scandal, a natural disaster, the endless churn of human drama that makes cosmic mysteries feel abstract and irrelevant. Within weeks, 3i Atlas was old news. The official narrative solidified, an unusual object with some unexplained properties. Interesting but not extraordinary. Worthy of further study but not worth getting excited about. The thermal anomalies? Probably modeling errors. The prime number sequence? Probably pareidolia. The human tendency to see patterns in random noise? The responsive signal? Never officially confirmed? Possibly instrument artifacts? Definitely not worth taking seriously. Case closed. Move along. Nothing to see here. But the data still existed. In servers around the world, terabytes of observations sat in storage, light curves, thermal readings, spectroscopic analyses, radar returns. The complete record of humanity's encounter with 3i Atlas, preserved in digital form. Most of it would never be analyzed. Most of it would sit untouched for years, decades, maybe forever. Science generates more data than scientists can process. Things fall through the cracks, but it was there, waiting. And somewhere in that data, maybe buried in a file that no one had opened, maybe hidden in a pattern that no one had thought to look for, there might be answers. Or maybe not. Maybe the data contained exactly what it appeared to contain. Evidence of something extraordinary that humanity wasn't ready to accept. Evidence that would sit in servers until the hard drives failed and the backups corrupted and the last record of 3i Atlas vanished into digital entropy. The universe doesn't care whether we understand it. The Japanese paper was never released. Whatever the team at Nobayama discovered on November 8th, Whatever made them go silent, whatever convinced them to lock their data away and stop answering emails, it remained hidden. Rumors circulated, of course. The heretics whispered about government intervention, about institutional pressure, about threats made behind closed doors. But no one knew for certain. Maybe the researchers had simply lost their nerve. Maybe they'd looked at what they'd found and decided that some truths were too dangerous to share. Maybe they'd realized that proving 3i Atlas was artificial wouldn't enlighten humanity, it would terrify it. Or maybe something else had happened. Maybe the third signal component had contained more than just a responsive pattern. Maybe there was a message in there, a real message, something that changed everything. And maybe the researchers had read it. Here's what we know for certain. For 8 days in October 2025, an object from another star system passed behind the sun. During those 8 days, we were completely blind. No telescope on Earth, no telescope anywhere, could observe what was happening. When the object emerged, it had changed, cooler than it should have been, more reflective than it should have been, spinning faster than it should have been, broadcasting signals that looked less like nature and more like engineering. Something happened during those 8 days. Something transformed 3i Atlas from an unusual object into an impossible one, and we will never know what it was. That's the part that haunts me. Not the anomalies, not the prime numbers, not even the possibility that something intelligent is out there. It's the blindness. It's the fact that the most important moment, the moment when everything changed, happened when we couldn't see. As if the universe had drawn a curtain at exactly the right time. As if something had planned it that way. Maybe it was coincidence. Solar conjunction happens. Objects pass behind the sun all the time. The timing was unfortunate, but not impossible. But maybe it wasn't coincidence. Maybe whatever was controlling 3i Atlas knew exactly what it was doing. Maybe it waited until it was hidden to activate, to transform, to wake up. Maybe it didn't want us to see. And that raises the question that no one wants to ask. If 3i Atlas was artificial, if something built it and sent it across the stars, then what was its purpose? Was it a probe? A scout? A sensor designed to gather information about our solar system and transmit it back to somewhere? Was it a messenger? A signal sent across the cosmos to announce that someone was out there, waiting to be found? Was it a test? A way to see how humanity would react when confronted with evidence of something beyond our understanding? Or was it something else entirely? Something we can't even imagine because our minds aren't equipped to think in those terms. We'll probably never know. 3i Atlas is leaving. It's already too faint for most telescopes to track. Within months, it will be invisible to anything except the largest instruments on Earth. Within years, it will be beyond the range of any human technology. And then it will drift through interstellar space for millions of years, maybe billions. Moving from star to star, passing through solar systems, being observed by whoever happens to be watching, or maybe not being observed at all. Maybe just traveling, existing, continuing whatever mission it was designed to fulfill. A machine with no endpoint, a message with no recipient, a question with no answer. The heretics have a saying now. They share it in encrypted messages, in late-night conversations, in the quiet moments when the weight of what they've seen becomes too heavy to carry alone. We looked at the stars and asked if anyone was there, and something looked back. It's not proof. It's not science. It's just a feeling. The bone-deep certainty that something changed in 2025. That the universe got bigger and stranger and more terrifying. That humanity's comfortable assumption of cosmic solitude was shattered, whether the official record admits it or not. They felt something look back, and they can't unfeel it. What happens now? Life goes on. It always does. People wake up, go to work, worry about bills and relationships and all the small concerns that fill a human life. The cosmic doesn't intrude on the mundane. The universe doesn't care about our daily struggles. But something has changed. For the people who saw the data, who really looked at what 3i Atlas did and what it might mean, something fundamental has shifted. The sky doesn't look the same anymore. The stars don't feel as distant. The darkness between them doesn't feel as empty. Because now they know, or at least they suspect. We're not alone. We never were. The pulse continues. Right now, as you watch this, 3i Atlas is still broadcasting. Still flickering every 4.7 hours. Still encoding prime numbers in its light curve. Still carrying its secrets outward, away from the sun, away from Earth, away from everything we know. What is it saying? Who is it talking to? Is the message for us? For something else? For no one at all? We don't know. We may never know. And maybe that's the point. Maybe 3i Atlas wasn't sent to give us answers. Maybe it was sent to remind us that answers aren't guaranteed, that the universe isn't obligated to make sense, That some mysteries remain mysteries forever, no matter how hard we try to solve them. We're used to being the smartest things around. We're used to figuring stuff out. We built civilizations. We split the atom. We walked on the moon. We sent probes to the edge of the solar system. But 3i Atlas reminded us of something we'd forgotten. We're small. We're young. We're blind in ways we don't even understand. And out there in the vast dark between stars, there are things that have been traveling for longer than our species has existed. Things that operate on timescales we can't comprehend. Things that see the universe in ways we can't imagine. We are not the center of the story. We're barely a footnote. The last clear observation of 3i Atlas was captured on November 23, 2025, a telescope in Chile. The same one that had first confirmed the anomalies months earlier. Recorded a final series of images, a faint smudge barely visible against the background stars, moving, fading, disappearing into the endless night. The pulse was still there, faint but detectable. One last flicker before the object slipped beyond the range of human instruments. And then, nothing. Just empty sky. Just stars that had been there for billions of years before us and would be there for billions of years after. Just the universe, vast and silent and utterly indifferent to our confusion. 3i Atlas is gone now. It came from somewhere we'll never visit. It showed us things we'll never understand. It passed through our tiny corner of the cosmos like a whisper, like a shadow, like a dream we can't quite remember upon waking. And now it's heading back into the dark, carrying its secrets, keeping its silence, leaving us with questions that might never be answered. But here's the thing. 3i Atlas isn't special. Oh, it's unusual. It's unprecedented. It's the most mysterious object humanity has ever observed. But it's not unique. The galaxy is vast, incomprehensibly vast. There are hundreds of billions of stars in the Milky Way alone, trillions of planets, countless comets and asteroids and objects drifting through the interstellar medium. We've detected 3 interstellar visitors in less than a decade. 3. And those are just the ones we noticed. The ones that came close enough, bright enough, slow enough for our primitive instruments to spot. How many others have passed through without being seen? How many are passing through right now? How many are on their way? The sky is full of visitors, most of them we never see. We're not watching closely enough. We're not looking in the right places. We're not equipped to detect the things that drift through the darkness on trajectories we can't predict. And the ones we do see, maybe they're not accidents, maybe they're not random. Maybe they only let us see what they want us to see. Think about that for a moment. If something intelligent is sending objects through our solar system, probes, messengers, scouts, whatever they might be, would they want us to notice? Would they reveal themselves to a species as young and violent and unpredictable as humanity? Or would they hide? Would they disguise their machines as comets and asteroids? Would they time their passages to avoid detection? Would they only become visible when they chose to, revealing exactly as much as they wanted and no more? 3i Atlas emerged from solar conjunction transformed. What if that transformation was intentional? What if we were meant to see the anomalies? What if the whole thing, the pulse, the prime numbers, the responsive signal, was a test? A way to see how we'd react? A way to judge whether we were ready? And if it was a test, did we pass? I don't have answers. Nobody does. The data sits in servers. The heretics keep watching. The establishment keeps denying. And 3i Atlas keeps drifting outward, carrying its truth into the void. Maybe someday we'll understand. Maybe future generations, with better instruments and clearer minds, will decode the message we couldn't read. Maybe they'll look back at 2025 and shake their heads at how blind we were, how close we came, how much we missed. Or maybe the mystery will remain forever. Maybe some questions don't have answers. Maybe some visitors don't want to be understood. But I'll tell you what I believe. I believe something passed through our solar system in 2025. Something built, something sent, something that looked at us and decided we weren't ready for the truth. I believe that 8 days of blindness weren't coincidence. I believe the silence from Japan wasn't natural. I believe the fracture in the scientific community wasn't about data or methodology. It was about fear. Fear of what we'd seen. Fear of what it meant. Fear of a universe that suddenly felt much bigger and much stranger than we'd ever imagined. And I believe 3i Atlas was just the beginning. There will be others. There are always others. Look up tonight. Look at the stars. The darkness between them. The vast, incomprehensible emptiness that stretches in every direction for billions of light years. Somewhere out there, something is moving. Something ancient. Something patient. Something that has been traveling for longer than our species has existed. Maybe it's heading toward us. Maybe it's already here. Maybe it's watching right now, waiting to see what we'll do next. The sky is full of visitors. Most of them we never see. And the ones we do see, perhaps they only let us see what they want us to see.